Hey guys, today's question is prime subtraction operation. In this question, we are given with the integer array nums, and what we can do in each operation, we can pick an index I which is not picked before, okay, and we can subtract any prime number which is less than the current number, okay. By doing these operations, maximum once time at every element, we have to return true if we can make the whole array increasing. Otherwise, you have to return false, okay, strictly increasing. Sorry. As we can see in this example, 4, 9, 6, 10. As we can see, here is 10, here is 6, so 6 is already not greater than equals to 10, so we won't do anything. Here it is 9, so we can choose any number, any prime number less than 9, and then we can subtract it from this 9. So let's say we choose 5, which is a prime number, and 9 minus 5 equals to 4. Okay, so we will replace 4 here, and now for this 4 we again want to change that because these both elements are 4 now, so we will choose any prime number 2 or 3, and then subtract from this 4, and the array will be strictly increasing, like 1 4 6 10 or 2 4 6 10. So what will be our approach is, first, as you can see, at every point we have to find a prime number less than equals to that element, which will make the vector increasing. Okay, so it is a greedy approach. Now to find every element in lesser complexity, because to find every element will every prime number less than this element will take about n root n like n root n about time complexity. So what we will do is we will use a sieve of Eratosthenes, and we will generate all the prime numbers in the starting. Okay, we will generate all the prime numbers, and we will make a prime numbers array that will store all the prime numbers in a sorted fashion. So what we can do when we reach 6, when we reach any element, and now when we want to change this element, like for this example third, this is 8, so we want to change this element, okay, because this is 3, so we want to change this element as 2 or less than equals to 2. So we want a prime number 6 or greater than 6, okay. So what we can do, if we want to take a element just equal or greater than equals to that in a sorted array, we will simply use lower bound. Okay, we will use lower bound, and then we will get the element, and if that element is not less than equals to nums of I, less than nums of I, then we can return false, because in this question already given that the element, that the prime number, pick a prime p, strictly less than nums I. So if the prime number is not less than nums I, then we will return false. Okay, so let's code it up to understand well. Initially, if the base condition, what will be, if the size is already just 1, then we can return true, because only one element, of course it is increasing. Otherwise, first we have to generate the sieve. So let's take a boolean vector, okay, to generate the sieve primes, maximum 1001, and this is the in given constraints, max value can be 1001. And now let's call the sieve function. Okay, let's pass the array primes. Okay, let's first write the sieve function that will generate the prime numbers. So void sieve. I assume that you all know what is sieve. If you don't know, just go and check any video, because it is a very important topic in DSA. So let's simply fill the sieve. So for int I equals to 0, I square less than equals to 1000, I plus plus. Now for int j equals to I into 2, j less than equals to 1000, wait a second, and j plus equals to I. Okay, and primes j will be false if it's dividing a value. Otherwise, and we will only check that those values which are not prime, which are prime. So if primes I is true, only then we will check. This is a simple sieve of Eratosthenes. Okay, so we have generated the sieve of Eratosthenes. Now at every index which is true, those are the elements which are prime. So let's take another vector to store to store the prime numbers in integer form. So let's name it as prime numbers, vector int prime numbers. Okay, we'll simply iterate over this boolean primes, and if the current value is true, then we will simply insert it into the prime numbers. Okay, so for int I equals to 2, I less than 1001 was the size, and I plus plus. Okay, now if primes I is true, that means the I is prime number, then we can simply push in the integer form. So prime numbers dot pushback. So after doing this work, the C of Rathasanus, what we got is the prime numbers array which have all the prime numbers sorted in the increasing order. Okay, now we have to do this work. So as I explained, we will iterate from right to left. For this time we can't do anything, so we will start from the last second value. Okay, if this value is less than 10, then we are fine. If this value is not less than 10, for example when we reach this 9, then we have to change this value which is just less than this value. Okay, that is a greedy solution. So what we will do is we will change this value to that, we will subtract this value to that prime number that will lead to this value just smaller than this value. Okay, so like for this 8, what we need to do, we need to subtract it by at least 6. Okay, because here is 3, so we have to subtract add by 8 by at least 6. Okay, so we'll find a prime number which is 6 or greater than 6. Okay, because 8 minus 6 is 2. If we subtract anything lesser, that will not give any value less than 3. Okay, so we have to subtract it by at least 6. Okay, so we can see the element that we have to subtract is nums of I minus nums of I plus 1 and plus 1. Okay, 8 minus 3 plus 1, which is 5 plus 1, which is 6. So we will use the lower bound to check which prime number is just greater than equals to 6. Okay, and then we'll subtract it by this value if and only if that prime number is less than this value. Okay, this is also given in the question. That prime number should be strictly less than that value. Okay, now let's iterate in the array from the last second element to first element. So int I equals to nums dot size minus 2, I greater than equals to 0, I minus minus. Now as we explained, as I said, if this element is lesser than the right value, then we are fine, so we'll simply continue. So if nums of I is smaller, then we are fine, we don't need to do anything, simply continue. And in the else part, first we need to find the value that we need to subtract, the minimum value, which is nums I minus nums I plus 1 plus 1. Okay, so int value that we have to subtract is nums I minus nums of I plus 1 and plus 1. Okay, because this element should be lesser. Now we'll find the lower bound of this value. Okay, we will simply use the lower bound function. So let's take our auto it equals to lower bound. Let me fix the screen. Okay, auto it equals to lower bound. Now array name is prime numbers dot begin prime numbers dot end, and the value that we have to find is value. Okay, so this iterator will store that index, the address, sorry. Now if this address is not equals to prime dot end, that means we have found an index. So if it not equals to the end of the vector prime numbers dot end, then we can check. Otherwise, if this condition not holds, we'll simply return false. Okay, else false. So if this condition holds, and also the, as I said, for this 8 the prime number can be 6 or 7. Okay, 7 is a prime number, but it should not be greater than or equals to this element. So we also need to check that condition. Okay, so what we will write in the AND part, and the value should also be greater. So asterisk it should also be lesser than the nums of I. Okay, nums of I should be greater, because the prime number that we can choose should be smaller. That is must. Okay, in that case we will simply subtract nums I minus equals to asterisk it, and in the else case we are returning false. Okay, and if the whole loop executes, we will return true simply. Okay, now let's run this. Okay, we did something wrong, I guess. Wait a second, let me check. We call the C function primes dot push back for I equals to number slide minus 2, I get equals to 0, I minus. Okay, value equals to nums I minus nums I plus 1, that is also correct. Lower bound function, and it not equals to primes dot end, and this value is less than, then we will subtract nums I minus equals to asterisk of I, else we will return false. Okay, let's, I think this one's, wait a second. Okay, we fix it. Okay, let's write it here, and in the else case of this return false. This one is okay. Let's submit this.